Hello, 1332 students. So this would be the second video talking about symbolic logic. And here I'm going to give you some examples of truth tables for some compound prepositions. I'm going to talk to you about how to construct the truth table. In the My Math Lab online Pearson material, they have a tendency to just give you the answer at the end, or ask you for the answer at the end, without showing you how people go about constructing those tables in a way that's easy and straightforward if you take your time and do it right. So for example, maybe you need to examine all the truth possibilities for the statement P and not Q. That's just an example, my first example. So that requires not just P and Q, but also a column for not Q. Some of the My Math Lab exercises do include that intermediary column, I would say, and later on you'll see in the chapter they just leave that out and jump right to the answer column. So to be able to discuss that, you need, if you're looking at that expression, you need to figure out how many columns to use, right? So if you're looking at this, say, okay, I need a column for just not Q, and then I'm going to look at the conjunction of that with P. So that expression there required 4 columns. The usual 2 starting in the usual order, make sure you do that. But we also needed an intermediary column for not Q, just to make it really easy. If you find yourself trying to hold a bunch of truth values in your head, you're going about it the wrong way, and you're making life really hard for yourself. When the expressions get more complicated later, you won't be able to hold all that in your head. So allow yourself to make a truth table. So in this chapter, make sure you have paper and pen next to you whenever you're given a question in symbolic logic. Then it's easy. Okay, so the usual setup for P and Q, both true, the first one true, the second one false, the first one false, the second one true, and then you end with both false. You put that down. So at first, I just have the headings, those first 2 columns. I have the 4 cases numbered just to keep everything straight. And then I start in. Now, some students find this difficult, but notice that not Q here has no reference to P at all. So to figure out what are the truth values of not Q, you just look at what Q is in each of the 4 cases. So if Q is true, not Q has to be false. If Q is false, not Q has to be true. In other words, just undo as you go from Q to not Q. Just undo all those truth values. Flip them. Now you can look at the expression P and not Q by looking at the P column and the not Q column together. So this requires you to just ignore Q for a minute and look at this and say, interpret that symbol. That's an and. True and false. Well, remember with conjunction, that's considered false. So yes, you're supposed to have really absorbed or memorized what the truth values are for a conjunction. So if you see the red dots, that's I'm focusing on what 2 values I'm comparing with this and. So true and true, that one's true. False and false, that's false. False and true, that's false. So then you have the answer column, which after a while, My Math Lab will just completely ignore that middle column and just give you P and Q, end result. But when you're creating it, allow yourself the intermediary column. Okay, so that was easy if you do it that way. Let's look at some more examples, a little more complicated. Okay. So let's see, I want to make sure you guys can see that. Yes, okay. So over here, so this time we are examining the truth values of the expression not, or it is not the case of the disjunction P or Q and P. That's awkward English, right? Some things to note. If you have a conjunction of P and Q, that is exactly the same thing as the conjunction of Q and P. That symbol is commutative, doesn't matter the order. Same thing is true of the disjunction. P or Q, same truth value as Q or P. That order does not matter. A third thing is to notice that we're using parentheses now, and parentheses dominate. Okay, so if I'm trying to evaluate this compound preposition, I had to break it up into a number of columns. I noticed I only have P's and Q's, so again, I only have the 4 cases of P's and Q's, the usual setup, true, 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 false, false, true, false, false. That was all done. Now I look at this and I say, what do I need to look at first? Inside the parentheses, I need to consider P or Q. So I write its truth values down here. Then what am I going outward from the parentheses? First thing I hit is the negation. It's like a negative sign. So multiplying by a -1. Very similar to taking the negation. The opposite, or the negation of the compound P or Q. That's what I'm going to put here. Finally, I have to compare this quantity and that. And that's what I'm going to be doing in this column. So, P or Q, the disjunction, the usual, hey, it's true in every case unless both are false. So you just put that down. What's the negation of this? This expression, its negation right here, I put it right next to it because then it's easy for me to just eyeball that I'm always flipping the truth value. What was true over here becomes false over there. This was false, now it's true. Now, to compare this and that, see the red dots I've put underneath here? I use, you have to keep your eye on these 2 different columns. I'm talking about P and not P or Q. Same thing as in this order. That's the comment about this symbol being commutative. It doesn't matter the order. So looking at P and the negation of this, true and false has to be false. True and false has to be false. False and false has to be false. False and true has to be false. Wow, look at this. No matter what the setup with with P and Q, no matter their truth values in all 4 possible cases, that expression is always false. An expression that's always false in all cases is called a contradiction. Your book is calling it a self-contradiction. I'm not really sure why they're having to add the word self. Contradiction will usually do it, but let's go with what they want because you have to answer their online homework. Okay, and quizzes. So they would call this a self-contradiction. This statement is false no matter what the truth values of P and Q put in. Very interesting. Let's try a third example. Here's the expression I have to evaluate. So first I had to say to myself, how many columns am I going to need here? Well, I'm going to need a column for this parenthetical expression. I'm going to need another column for that one. And then another column to compare these 2 in this conjunction. Okay, so I made the usual P and Q. Inside those parentheses, I had a P and Q. Inside those parentheses, so that was a conjunction. This was the disjunction. And in the final column, I'm going to be evaluating that and right there. Okay, so for P and Q, their conjunction always has these values. Only true if both were true. With a disjunction, it's always true unless both were false. All right, so you should be used to those 2. Now let's compare these 2 columns. See the red dots? That means I'm using my eyes on these 2 to compare with that symbol. True and true is true. And just say out loud what that symbol is. That's and. False and true, that's false. False and true, that's false. False and false, that's false. Now, is this statement a contradiction? No, because sometimes it's true, sometimes it's false. It's not always false. If a statement had all truth values there, you would call that a tautology. Something that's always true. All right. So most of the time, things are neither a contradiction nor a tautology. This one is neither a contradiction nor a tautology.